Hello all, good evening. In today's class, we are going to discuss about flavonoids, an introduction about flavonoids. So we all know that flavonoids are an important secondary metabolite. It possesses a lot of pharmacological effects. So we'll see each one by one. These flavonoids are an important class of phytoconstituents present in all plants. So in general, flavonoids are present in all the plants. And they are 15 carbon compounds with a general formula of C6, C3, C6. So the general structure of flavonoid is it contains three rings. We'll name it as A, B and C. A ring, B ring and C ring. Right? So this A ring and B ring is a benzene ring, will be a benzene ring, whereas the C ring will be a heteroatom containing ring. It's a heterocyclic ring. Okay, and the most common heteroatom will be oxygen. Not most common, oxygen will be the heteroatom. And the total carbon that will be present in the basic ring structure will be 15. So flavonoids are 15 carbon containing compounds with a formula of C6, C3, C6. This C6 are benzene ring, C3 is the heterocyclic ring which contains oxygen as a heteroatom. So these compounds generally present in plants as flavonoidal glycosides. So these flavonoids in the plants are present as flavonoidal glycoside, which means that these flavonoids are linked with your sugar moiety and present as flavonoidal glycoside in the plants. So as we said earlier, the basic structure has three rings, A, B and C. A and B ring is a benzene ring. C ring is a heterocyclic ring which is containing this oxygen as a heteroatom. Right. So the flavonoids along with carotenoids are responsible for the flower color. So we may see in a lot of flowers possessing different colors starting from white to various color combinations, right? So the color of these flowers are due to these flavonoids and carotenoids. We may hear about these carotenoids, right? Terpenoids which is present in large amount in carrot, so that it's called as carotenoid actually. We'll discuss about it in a separate class. So the flavonoids along with carotenoids is responsible for a variety of variety of color in the flowers. So based on the combination of the flavonoid, based on the type of flavonoid present along with the carotenoid, the color of the flower is determined. These compounds are generally yellow in color. Generally flavonoids are yellow in color, but when these flavonoids getting combined with the carotenoids, the color will get changed, right? So the general color of flavonoid is yellow. These flavonoids exhibits various properties such as antioxidant, anti-cancer, anti-allergic, antiviral and anti-inflammatory property. The main pharmacological effect of these flavonoids is it is a potent antioxidant. So it is having the capacity of neutralizing the free radicals present in our body. So if your compound is having a potent antioxidant effect, then it will be having a lot of health benefits. It will be preventing our body from lot of diseases or disorders. So that only in the beginning we told that these flavonoids are a very important class of secondary metabolites, very important phytoconstituents, since it is having an antioxidant effect. So other than antioxidant, it also has antiviral. So it is having antimicrobial property also, and it is also having anti-allergic property. So based on the type of flavonoid, based on the flavonoid present in the particular plant, these pharmacological effects varies. But in general, flavonoids possesses antioxidant, antimicrobial, anti-allergic effects. Right. So the classification of flavonoids includes 5 types: flavonols, flavones, isoflavones, and flavonoids. So there are 5 different types of flavonoids, and these category is just based on the functional group or else the chemical structure. So based on the chemical structure, the flavonoids are classified into these 5 categories. So we had listed certain examples also for it, right? And how to identify these flavonoids are, so in general, these flavonoids gives yellow color when sodium hydroxide is added. So with sodium hydroxide, flavonoids will be giving yellow color. But we could not able to exactly identify flavonoids using this test. And we can confirm flavonoid just by doing Shinoda test. So in this Shinoda test, our sample will be treated with a magnesium metal and hydrochloric acid, and if it gives violet color, then it means that flavonoids are present in that particular crude drug, right? So Shinoda test is the confirmatory test or the significant test that has to be done to confirm, to identify the presence of flavonoids, right? Thank you very much. In tomorrow's class, we'll see you. Thank you.